Good evening, everyone. Thanks for spending the time with me today. I want to talk a little bit about artificial intelligence and machine learning, and specifically on how we can do that with Amazon Web Services, some of the new announcements. And I also want to showcase a variety of use cases that we see from our customers, but also within the broader Amazon kind of company. And I want to start with level setting the conversation. I've noticed that very often, even in our industry here, a lot of people use these words of deep learning, machine learning, artificial intelligence interchangeably. And they kind of all belong in the same bucket. But you kind of got to look at it from a perspective of artificial intelligence is the implementation of machine learning models that we fit on top of existing data points or on data points where we continuously learning from. And deep learning, which is a technique of using deep layer neural networks, has really helped us to make a lot of progress in a variety of different domains. Notably, in the domain of automation and robotics, in the domain of natural language understanding, processing, and also automatic speech and voice recognition, and lastly, computer vision. We see an explosion of some of these use cases because deep learning, which is computationally intensive, is now available to us at a fraction of the cost given to the power of services like AWS and cloud computing as a whole. I want to go to some of these use cases and have a look at our machine learning and AI stack and how it applies for you to be able to build something on top of AWS cost effectively. If we start with automation and robotics, in the videos just earlier, you saw some of these robots stream around. These robots, these little orange Kiva robots that are under the shelves in some of our fulfillment centers, are part of our Amazon Robotics department. We got hundreds over thousands of these that run in a variety of fulfillment centers, and they help with the picking process. And the idea here is not only making the picking process a little bit more efficient, but also compressing the size of the fulfillment center by being able to stock all the goods in a more effective manner. This is a good example of where robotics, with the help of machine learning, with the help of computer vision, allows us to be operationally more efficient. One of the other areas, which I'm very excited that we announced this 3 weeks ago at our reInvent conference, is we want to help you as customers and partners to be able to do robotics more effectively. And so we announced actually a service called AWS RoboMaker, where the idea is how can we help you to easily develop, test, simulate robotics application, intelligent robotics application, and then deploy them out and run them at scale. So this comes with the capabilities of building complete simulation environments, training your robot, using machine learning components to understand how your robot operates, and I'm going to dive a little bit into that in just a bit, and then deploy it out to your robotics fleet. Now, I said natural language understanding and processing. If you think about an Amazon Echo device and the Alexa voice services, if you happen to have a device at home, this is a good example of how we make use of machine learning services or machine learning algorithms, both at the edge, meaning the speaker, the device itself, because if we trigger the wake word, Alexa, which, by the way, that's the default wake word, if there are any Star Trek fans in the room, you can switch that also to computer. So you can say, computer, tell me what the weather is like. That wake word is a machine learning model that runs on the device itself. But then the logic and all the skills behind it run on AWS. Alexa Voice Services, which is another part of the Amazon company, is a customer of AWS, and they train those voice and natural language processing model on top of AWS. Now, if you think about computer vision, how is computer vision applicable? I mean, if you went outside, there are plenty of booths of wonderful startups here and partners that are leveraging computer vision for a variety of different use cases. I want to share with you another one here with the broader Amazon kind of company, which is Amazon Fresh, which is currently not available here, but available in the US. It's a grocery delivery service. And the problem with groceries is if you shop them online, vegetables, fruits, etc., there's no way to actually look at them, right? There's no way of smelling them or sensing them if they're ripe, if they're good to be cooked or eaten. And so this is one of the challenges that you have when you ship this out, because we want to make our customer and consumers happy and not ship them, for example, strawberries that wouldn't be fresh or wouldn't have been ripe yet. So one of the things that you can do with computer vision, as an example, what you see here is in that packing station, before we send it out, there's actually a little camera, maybe a little bit hard to see here, There's a camera that actually uses computer vision and tries to analyze, okay, in this scenario, strawberry, we do it on a variety of different vegetables and fruits, and tries to identify, okay, where do we have serious damage on a strawberry? What is ripe, what is not ripe yet? And it allows us then to remove the bad strawberries, discard them, and only ship out the ones that makes our customers happy. So these are good examples of how we can use technologies such as computer vision, natural language understanding, and specifically machine learning models using deep learning to actually enable use cases. Now, what is our mission within AWS? So our mission is to make machine learning and artificial intelligence services available pretty much to any developer, to any data scientist, to any IT professional out there. The idea is how can we democratize machine learning? Something that used to be a field of experts, we want to make it available to anyone out there to be able to build your business and your applications and enrich them with artificial intelligence components. Now, Navdeep already mentioned this. We kind of look at it threefold. 3 different layers on how we want to enable customers and partners on how they can make use of machine learning services. The top layer is the fully managed artificial intelligence services that we provide you with. So all you need to do is you make an API call or you use our software development kits, and you can immediately get access to artificial intelligence services in the space of computer vision, speech, language, chatbot functionality, personalization and recommendation, and also forecasting services. All of these services are fully managed and trained by us, and we continue to enhance them with new features and functionalities based on the feedback that you provide us on those services. Key point here, I don't need to have any machine learning expertise. I don't need to understand any of the artificial intelligence of deep learning models. All I need to do is, with a click of a button, I can get access to these services. The second layer, machine learning services, is how we want to enable any company out there to say, I have data points. I have data for my customers, for my business. I want to train my own machine learning models, but I don't want to understand how those algorithms work, or I don't have data scientists at hand that can help me with those. And that's where elements such as Amazon SageMaker come in, and a variety of other things that I'm going to talk through in a little bit. Key point here, not only are we, as an Amazon company, taking our machine learning algorithms and we make them available for you, we actually created a marketplace where any company out there can create machine learning models and algorithms and can make them available to the marketplace. And anyone out there can now start consuming those machine learning algorithms without the need to ever write a single line of code in any of those machine learning frameworks. And then the last, bottom layer is how can we bring down the cost of running machine learning overall from a framework perspective, from an interface perspective, but also from the underlying hardware infrastructure perspective. If we can make hardware infrastructure available at a fraction of the cost at large-scale nodes, we can bring down the training and the inferencing costs that we have in the machine learning space, effectively allowing businesses to actually make use of machine learning at a fraction of the cost. Navdeep already mentioned, we announced a variety of new capabilities during our annual reInvent conference around having very powerful instances that allow us to train and infer from machine learning models at very large scale. AWS Inferentia is a custom-built chipset that allow us to perform machine learning inference effectively on a variety and all kinds of different frameworks. Now, one important element from AWS's side is we always want to give you options. If you look at our compute, our storage, our database offerings, we always want to give you options. We want to give you options to run with the frameworks, the tools, and the systems that work best for you as a company, that work best for you as a business, and also what you feel most comfortable with. And our mission in the machine learning space is exactly the same thing here. So if I want to focus on the bottom layer first, and then we work ourselves up, our mission here is we want to give you the capabilities of any framework that you would like to use and make those frameworks not only work on AWS, but optimize those frameworks for your training and machine learning inference models on AWS. No matter if it's TensorFlow, or MXNet, PyTorch, Chainer, the ONX, which is the Open Neural Network Exchange that allows you to build a model and have it in a variety of different frameworks, Keras, Gluon, which are interfaces, and many others. The key point and the idea here is we run those either way fully managed for you, optimize them from the underlying infrastructure, meaning being able to train at a fraction of the cost using those frameworks, or you can run them yourself. We don't want to force you down to a single framework. We want to give you the capabilities of what works best for you and within your business. And just to give you an example of how these frameworks really help to move capabilities forward, there's a fast food company in the US called Chick-fil-A, and they have, for example, these waffle fries that you see here. And they use the framework called MXNet, which is one of the popular machine learning frameworks. And within a very short period of time, their team, which had absolutely no machine learning expertise, managed to build a computer vision model with a camera that looks onto the fries, and it can identify which fries have exceeded their hold time, right? Which ones are still fresh, can be served, and which ones should be discarded because they exceeded their hold time. The interesting thing here is, in a very short period of time, with no prior machine learning expertise, these frameworks make machine learning available to everyone out there with very little prior knowledge within that space. That's fundamental. And when I say we want to make it available on any kind of frameworks, I really mean that. I flashed out the big frameworks that a lot of people know, TensorFlow, MXNet, Caffe, etc. But any framework can be used. I actually want to show you a live demonstration right now with a framework that is called Darknet. It's an open source framework that was created by Joseph Redmond, who's a researcher at the University of Washington State. And you can use that framework to train on top of the AWS infrastructure and build your own computer vision models. Now, what do I mean with that? Let me demonstrate to you what such a framework can do. We can just switch over. Thank you very much. So what I brought here with me is a very normal camera. It's a Sony CyberShot, nothing special. But I'm going to pipe in via HDMI that video stream into my laptop here, and I'm going to run a machine learning model in Darknet on top of this to identify most commonly seen objects in real time. And so if I just hold this out here, you can see that in real time we can identify a variety of things. And if you wonder, hey, I saw a suitcase out there, that's a perfect example of how machine learning works. If I just pull this over a little bit, you can see that we also have a percentage of how accurate this is. Now, the key point of what I want to show you here is how fast, whoops, just a little space here, how fast these models have become. And you can see the reactivity of this model as I move around is pretty fast in terms of the size and shape. And I'm able to run computer vision models effectively in real time without any specialized hardware here with an open source framework that we're seeing. Right. Thank you very much. We can go back to the slides. And later we're going to see a few other examples during the session with Intel on how we can run that on some custom edge hardware also to run that a little bit more effectively. The key point here is you have capabilities now at hand of building computer vision models like this in real time, something that just a decade ago was unthinkably hard. I can now do it without writing a single line of code and training it on my own models that I want to have. Another element that you find is when you run machine learning models, one of the challenges that you have is you require the underlying capabilities of very often GPU hardware acceleration. Now, we provide you with very beefy instances where you can train machine learning models effectively at very large scale, but you find that actually, if we talk to customers, what is the biggest cost component of operating machine learning? And you find that actually training a machine learning model is often just a fraction of the cost. Very often, it's just 10% of the actual cost that they're spending, and 90% of the cost they're spending on making predictions with those models. And why is that cost so large? Because there's wastage. Very often, you want to run a machine learning model, so you got to get a GPU instance. Now you have a big GPU, but you actually don't use 100% of those capabilities. So we thought about it, and we said, how can we make that better and more cost-effective for our customers? And that's why we launched something called Amazon Elastic Inference, which now allows you to attach GPU inference capability to any kind of EC2 instance, to any kind of Amazon SageMaker workload, at those GPU acceleration just to make your predictions in your machine learning models. at very small scale increments that are available from 1 up to 32 teraflops. And the key point here is it gives you granularity, right? If you don't need the full-size GPU, now you get granular increments at a fraction of the cost. And we find that with these capabilities, in most customer workloads, we now get up to 75% cost savings. These are a fundamental game changer because if we can bring down the cost of machine learning models, we can create new business use cases. Let's move to the second part of the stack. I talked about, you have your own data points available, but you want to train your own machine learning models, but you don't want to actually understand how these machine learning models work. This is where capabilities such as Amazon SageMaker come in that allow you to use inbuilt algorithms that we provide or that are provided through the AWS Marketplace for machine learning, where you can use pre-built machine learning algorithms for object detection, computer vision, document processing, what have you. A variety of many different use cases that you can now leverage, train it with your data in your environment, and off you go and you have a functioning machine learning model. What you see here, for example, earlier you saw a snapshot of that video, is a company called TuSimple. Now, TuSimple actually builds computer vision models to do object detection, and these are useful for autonomous vehicles or assisted vehicles that are driving around. What you see here is actually a car that is driving to the streets of Beijing, and if you are not able to read the Chinese characters, actually it also classifies not only that there is a vehicle, but it actually gives you the brand, which in this scenario would be a Volkswagen, right in front of us. The key point here, and they have built a lot of different computer vision models on top of it, these are the baselines that we require to build autonomous vehicles. At reInvent, we also announced that Mobileye, an Intel company, is a customer of AWS. They are building the fundamental underlying machine learning models for assisted vehicle driving. If you have a car that has a park assist, very likely that it was built by Mobileye. Again, here the idea is how can we bring down the cost and the capabilities of running those machine learning models? With Amazon SageMaker, if you want to build an object detection algorithm, all you need to do is you bring a bunch of video material and pictures, and you say, here is my object that I want to detect. The machine learning model will learn from it, and off you go. So these capabilities that not too long ago were a domain of experts, now is at hand for everyone to use. Now, one thing, though, that you find is if you build machine learning models like the one you see, you start off with raw material, and then what you need to do is you actually need to annotate that raw material first before you can train your machine learning models. I call it the artificial intelligence, meaning a human being. Right? And that's a lot of work. So we thought about it and we said, okay, what can we do to make that, again, easier for our customers? A lot of effort goes into annotating and labeling data sets before we can train machine learning models. And so that was one of the reasons we announced a capability which is called Amazon SageMaker Ground Truth. And the idea here is how can we help you build accurate training data sets at a fraction of the cost and at a fraction of the time so that you can move faster on training your machine learning models. How does that work? Well, basically, you take your raw data and some small subset part of that data, you actually use human annotators, which, by the way, Ground Truth gives you capabilities to use either way annotators of your own company, annotators of some of our partners out there, or annotators of Amazon Mechanical Turk, which is one of these services where we have human annotators here. And then we have an active learning model behind in SageMaker Ground Truth, which will now identify, hey, based on what you annotated, I can automatically annotate a good chunk of your data set. And the ones that I cannot annotate, well, I can pass back to the human annotators. And off you go. You have now a labeled and an annotated data set that you can use for training. Again, reduce the cost and accelerate the speed at which we can move forward to actually train machine learning models. Now, the other thing that we sometimes have is when we talk to customers, some of our customers say, hey, look, that's all great, but I actually don't have data. I don't have data yet. Okay, great, here are ways to start collecting information and data. But sometimes you don't have the capabilities to actually have data at hand, but you still want to start training machine learning models. So what could we do about that? So what you find if you look at the different kinds of types of machine learning, and this is a very rough structure, you can broaden the spectrum, but if you roughly want to look at it, you have kind of the supervised machine learning, the unsupervised machine learning that was available, and a very new, interesting space where we say, okay, we actually don't need to annotate data, but we learn based on behavior, is a space called reinforcement learning, or RL in short. And so reinforcement learning is really useful because what it allows you to do is you can say, I create a simulation environment, right? That can be a complete simulation, or it can be a real-time kind of environment where we continue to push that back into the simulation. And then we create a scoring function, meaning a positive and negative reward. You do something, it's good, continue with it. You do something, it doesn't work so well, it's bad. Remove it, change your course. And then the reinforcement learning algorithm can learn from it. Very useful in the space of robotics, manufacturing processes, supply chain, autonomous cars, drones that are flying around. Reinforcement is very useful here. Let me give you an example of and this is one of the capabilities, again, that we want to make available to you. So reinforcement learning can be hard when you start from scratch, but we wanted, again, to make that available to our customers. So Amazon SageMaker RL, which stands for reinforcement learning, is now a new capability that's available for you today within SageMaker that allows you to run and train reinforcement learning models using SageMaker. What does reinforcement learning mean? Well, what you can go ahead and you say, I'll give you an example here of Harry, our little runner that tries to run. How does reinforcement learning work? You create a simulation environment. In this scenario, it's a little running track and a little figure that tries to run. You start off with your first model that hasn't learned anything yet, and you put it into your simulation environment. Now, what happens? That runner tries to do something, but nothing happens, right? He doesn't know how to run yet. Now, what you're going to go ahead and you do is you say, every time you add a certain action, which your reinforcement learning agent does, he gives new actions, and then you look at the observations, right, in your simulation environment. So you simulate and you say, okay, based on this action, you seem to progress. Based on this action, you seem to fall down. What happens next is the reinforcement learning model slowly starts to understand, hey, if I balance my body a little bit, maybe I fall forward. And if you continue those iterations, slowly you have Harry who's able to kind of non-elegantly move a little bit forward. And then the next thing what you do is, basically on these actions and observations, you collect new training data. That process of actually doing reinforcement learning yields data. That data can be used to now push back into SageMaker, improve your model, and then push that model out, again, update it into your simulation environment. And if you do that often enough, you get to a situation where Harry has learned how to run without you telling him how running actually ever works. And if you want to extend that, you can put some obstacles or make him dance or what have you, all to the help of reinforcement learning. So without ever the need to understand how the running actually works, we learned how to run. These are fundamental capabilities because it helps us to build machine learning models when we don't have data at hand. So in that same kind of gist, we thought, how can we get developers rolling with reinforcement learning, literally rolling? And so we launched something called the AWS Deep Racer, which is a fully autonomous and one of the 8/10 of scale small little race car, which is driven by reinforcement learning. It's a physical car that you can actually use, and you can use it to experiment and build reinforcement learning models against that race car so that the race car can slowly start to race around. What you see at the bottom is a little video of something that runs, a simulation that runs in AWS RoboMaker. Right, so AWS RoboMaker, the service that allows us to build out robotics kind of applications, we can use it to train and simulate the reinforcement learning model for the car so that eventually it can autonomously drive a circuit by learning through reinforcement learning. And one other thing that you find is this, especially when we get to the scenario of such a physical device, when we train a machine learning model in my cloud environment, I need to push that sometimes out to different pieces of hardware. Right? There are different kind of underlying chipsets that are available. And again, this is something where a lot of our customers have told us, look, I want to use different kinds of hardware. It's complicated to port it to different kind of hardware. Can you make it easier for us? So we launched something called Amazon SageMaker Neo, which allows you to take some of the most common machine learning frameworks, such as TensorFlow, PyTorch, GMXNet, etc., and actually compile it for the respective underlying infrastructure and hardware that you have at the edge location and optimize it for that piece of hardware. So again, give you the capabilities of saying, don't worry about the underlying infrastructure, even if it's within your own premises, use this to deploy it effectively out there. And then so the last part before I hand over to the panel, we want to look also at the fully managed AI services. And I mentioned earlier here, we have services around computer vision, facial recognition, object detection, translation, transcription, etc. And we also launched 3 new services at re:Invent. One is called Amazon TextRact. And Amazon TextRact was something that a lot of our customers have asked us. They said, look, we have documents lying around. Can you help us being able to understand those documents better, right? Because they started off using plain OCR, and OCR is kind of okay. It allows you to recognize text, but it's all kind of a big blob of text. It doesn't give you the right insights. And so we launched Amazon TextRact, which is a way of extracting information out of documents, right, or snippets of pictures that you have intelligently from any kind of document, extract not only the text, but understand what are the key value pairs. If there's a table, I want to understand the table. I want to understand where's the boundary boxes, so we can extract information out of those documents. Again, fully managed, so no machine learning experience required. Just an API call away. And in the similar gist, we went ahead, and a lot of our customers have said, hey, you are Amazon, you also have Amazon.com. You got all these cool recommendation and personalization things. You got your forecasting, machine learning models. Can you show us how to do that? And we said, we can, but you know what we also can, and that's better. We give you the fully managed service for it. So we launched, in preview currently, Amazon Personalize and Amazon Forecast, which is both a service that allows you to personalize and build recommendation engines with the same technology that Amazon.com is using, and build your own forecasting models with the same technology that Amazon.com is using. Again, no machine learning experience required, no frameworks required. You just start using it. So again, as the last message, it is our mission to put machine learning and artificial intelligence into the hands of every developer, any IT professional out there. It is multi-layered. If something here is of interest for you, please talk to us. We're happy to work with you and define what would your machine learning stack look like and how we can help you do that at a fraction of the cost and potentially optimize what you currently do within your environment. So with that, I want to thank you very much for your attention. Thank you.